So we're going to first look at regular polygons. So I'm going to click regular polygon and, oh, there we go. Vertices, I'm going to have 3. Now, when I do this, I'm actually going to colour it pretty nice. So I'll go blue and I'm going to make it like so. Oh, come on, off you go. And line thickness quite thick. That's fine. Okay. Now I'm going to get a slider. I'm going to pop my slider here and I'm going to start with 3 because you have to have at least 3 sides. And I'm going to go up to 15 because I think that'll be quite enough. An increment of 1. Adding on. And I'm going to call this here, I'm going to call it sides. Okay. Oh, didn't like that? Okay. Apply. And then I'm going to make that very fat. Okay. Now I'm going to go back to object properties, and instead of the 3, I'm going to call it sides. Okay? Oh dear. Oh dear. Let me try again. Object property. Capital S, I, D, S, sides. Okay. Okay. So I'm going to animate that. Alrighty. So now what we've got is regular polygons produced by Geogebra. So we have equilateral triangle, square. It's going a bit too fast. Yeah, very, very quickly. But they're all regular. All the sides are the same length and all of the angles are the same size. So they're very special shapes. Now, if I just pause my animation, we'll just look at the ones we're worried about. So there we've got a triangle. That's an equilateral triangle because all of the sides are the same length and all of the angles would be 60 degrees for an equilateral triangle. Then we're going to make a square. Okay? So 4 equal sides, 4 equal angles. All the angles are 90 degrees. Then we've got a pentagon. Now, when we're looking at our Platonic solids, which is back here, a Platonic solid is a 3-dimensional shape made out of regular polygons. Now, these are the only possible ones. My favourite being the dodecahedron. Okay, so you can actually click on here and you can get the net of a dodecahedron and make one yourself, which is fun. You could do that. Could be good homework. Icosahedron, spin a dodecahedron, and you can have a look at glass like that. I quite like it like that. You can explode it. You can spin it manually, pop it back down. And now we can actually have a look at the polyhedra on Maths is Fun. So the dodecahedron is one of the Platonic solids. A cube is a Platonic solid. A triangular prism is not a Platonic solid because it doesn't have all those properties of symmetry. It doesn't have that same regular polygon forming this 3-dimensional shape with like perfect symmetry, if you like. So I'm going to have a look here at prisms. And your prism has the fact that it's like a child's toy that you slot in. I actually made a video on that. So the cross section's the same the whole way through. You get the area of that cross section times the length. This here is a cylinder, and you get the area of the circle times the height. So the rule is the same, area of the base times height, but it's actually not a prism, it's actually a cylinder. So here we have a square prism, so that's the cross section. You get the area of that times the length for the volume. Here you've got a cube, area of that times the length, but the length is the same as the width is the same as the length. So, you know, if you've got 2 by 2 by 2, 2 cubed is 8. 3 by 3 by 3, 3 cubed is 27. Yeah, and 4 by 4 by 4, 4 fours are 16, 16 fours are 64. Yeah, you've got it. Those are cubed numbers, right? Triangular prisms and pentagonal prisms. And then you can have all sorts of strange shapes of a polygon. It's irregular because it's not that regular shape, but you can still have a prism. So you still get this area times the length for the volume. There you have your formulas. So the volume of a prism is the area of the shape that stays the same the whole way through, if that makes sense. There's a bit of a misprint here because the sides of a prism are not parallelograms, they're actually rectangles. Okay, so that's okay. See, to me, I'm not seeing that so much as a prism. Well, it's not a sort of a prism that you would meet, say it that way. Oh, no, it's not a prism. Okay, so here where they say the sides of a prism are parallelograms, no, they're rectangles, which is a special parallelogram. Okay, moving on down, and you can do the questions. And the questions get you to the Mathopolis that we were looking at before. Alrighty?